Solve the following equation. For this radical equation, the variable occurs as a linear term within two separate radicals. For this case, the entire equation must be squared twice in order to remove the radicals. First, isolate one of the radicals and square both sides. This will remove the radical that was isolated, but the side where the radical was not isolated will still contain a square root. Then isolate the other radical and square both sides again. This will remove the second radical. This will result in a quadratic equation. We solve that resulting quadratic equation and then check the answers and reject any extraneous solutions. In this case, the left side of the equation containing square root of 3x plus 2 is already isolated. We simply have to square both sides. We end up getting 3x plus 2 when we square the square root of 3x plus 2. This is equal to 2x plus 1 plus 2 times the square root of 2x plus 1 plus 1. Note we still have a radical on the right side of this equation. We have to isolate the term containing that radical. We can combine like terms first. 1 plus 1 giving us 2. We then will subtract 2x and 2 from both sides. This gives us x equals 2 times the square root of 2x plus 1. We now have the term containing the radical isolated. We can square both sides. This now gives us x squared equals 4 times 2x plus 1. We can expand through the brackets and move everything over to the left side of the equation, giving us x squared minus 8x minus 4 equals 0. This quadratic expression does not factor. We could solve this by either completing the square or using the quadratic formula. I'm going to plug the a, b, and c, 1, negative 8, and negative 4, into the quadratic formula to solve this equation. We get x equals 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 4, all divided by 2 times 1. This results in 8 plus or minus the square root of 80 over 2, or 8 plus or minus the square root of 16 times the square root of 5, which is 4 root 5, all over 2. Note now we can cancel out the 2's on the numerator and denominator. This results in x equals 4 plus or minus 2 root 5. We then have to check our two solutions. First of all, let's check x equals 4 plus 2 root 5. Substituting this, we end up getting a left side of 5.24, and the right side also equals 5.24. This solution is therefore a good solution. Substituting x equals 4 minus 2 root 5, the left side equals 0.76, the right side equals 1.24. In this case, the left side does not equal the right side. Therefore, 4 minus 2 root 5 is an extraneous solution. The solution then to this equation is equal to 4 plus 2 root 5.